Hello, everyone. Welcome to today's event. My name is Hadeel, and I'm very excited to present to you today's event, which is a part of a three-part series. We've already done two, and today we'll be talking about a dive into the data analytics journey, data processing and analysis, which is the last stage in the data analytics journey that we will talk about. Very excited to have you here all, and also hello to the online audience from wherever you are joining us in the world. Very excited to have you all with us, and thank you for being here. So let's begin. So just a brief reminder that this Microsoft event has a code of conduct. So just be welcoming and be respectful, be open to all questions and viewpoints, be kind, be considerate, and most importantly, be friendly and be open. We're all here to learn, so just let's make this a very smooth learning journey as much as possible. So, who is your speaker? My name is Hadeel. I am a regional cloud advocate and data analytics engineer for Microsoft Reactor, Middle East and Africa. Now, part of what I do is I give sessions just like this in the Microsoft Reactor, in tech hubs and such, in order to kind of educate you and learn with you on concepts. Specifically, my areas are in data analytics, data science, artificial intelligence, machine learning, as well as exploring other tech fields. If you would like to connect with me, you can find my LinkedIn and you can find my Twitter handle here as well. I would love to connect with all of you, and that's it. That being said, let's look at what we will be learning today. So today we will briefly go over the data science lifecycle, just go over the overview. We will talk about what data processing is, what data analysis is, why they're important, and kind of also the steps we need to take when you start any data science or data analytics project. And then we will start by defining the machine learning algorithms that we have to use when it comes to data modeling. And then we will walk through a continuation of the example that we've already started in the previous two stages as well. So what is data science? Data science is the science of data. We use scientific techniques, methods, and tools in order to transform our data from raw data into valuable insights that will help us make better decision making. So data science is kind of an iterative process between three things. First of all, you need to kind of understand and have a knowledge of what is happening today, and then collect the data that you have in hand, and then kind of answer the questions that are being asked. So data science kind of holds all these three together and kind of helps you understand and answer these questions. So let's go through briefly the data science lifecycle. We've already talked about it and touched upon it the last two times. However, just as a reminder, and in case we have anyone new joining us online or any new members here, so the data science process starts with, obviously, you have raw data, and raw data can come from sensors, from devices, from anywhere you can think of. And then you would start by processing your data. What that means, you would look at your data, you would kind of look at how, if you have missing values, if it's messy, if you have like unused columns, if you have numbers that don't make sense, you would have to go through a data preprocessing and cleaning stage in order to make sure your data set is clean and ready in order to have a clean data set. After you have a clean data set, you will start as a data analyst or a data scientist by exploring your data. And what that means is this step is called exploratory data analysis. And basically, you are looking at the data to kind of discover any trends, any unhidden patterns you have, and kind of summarize the most important statistics or the most important features you have in the data set in order to produce the output you are looking for. After touching upon exploratory data analytics, we will go into today's topic, which is data processing, which involves building models and algorithms. And then we will do visualizations, based on the raw data. So basically transforming our raw data into visual figures like plots, box plots, charts, histograms, any kind of plot you can think of. And then we will have the initial data product or the output that will help you be able to make better decision making or even build even more valuable insights based on what you are trying to solve. So this is kind of the life cycle that it follows. Now, this life cycle involves stages for identifying and managing data, while kind of data analytics is the process of analyzing the data. So as I mentioned, we already explored the first two stages. We explored the data cleaning and pre-processing step, and then we explored exploratory data analytics and visualization. Today, we will be talking about data processing and analysis. But before we do that, I just want to remind you of what we did last time very quickly. So obviously, the first stage we have to do once you have a data set in the hand is you need to pre-process your data and clean it in order to get rid of any kind of messy data that you have. And with that being said, when we checked our data set that we have, we found that we had missing data, we had columns that are not relevant to what we are trying to solve, we needed to convert categorical, non-numerical data into categorical, numerical data, and we had to normalize our data using the minimum maximum normalization, which is one of many methods of normalization. And that means you standardize your data ranges between 0 and 1. Next, we explored our data, and this helped us kind of give our own insights and build and kind of discover any unhidden patterns that we had. And, we used it to discover any trends and to kind of also highlight the most important statistical summaries that we have and features in our data set. And obviously, exploratory data analytics is a very good starting point for helping you kind of define and have a framework for future studies and getting to know your data that you have in hand in order to build deeper insights moving on. And then we visualized our data. We talked about, the different types of visualizations we have, why we use each one, and such. So we have data visualizations from graphs, maps, histograms, box plots, charts, and such. And obviously, we use data visualization to kind of, summarize all the raw data that you have in hand and present it into visuals that will be easier for you to present to your stakeholders or be easier for the audience to understand. So let's talk about data processing and analytics. So obviously, much of the data management we have in hand is all about extracting useful insights and information. And in order to do that, we need to take our data, and it has to go through a data mining or data modeling or data processing kind of process in order to have meaning from it. Because most of the data sets that we have in hand, they don't really make sense. They're just numbers, they're just random, all these random values. So in order to make sense of the data, it has to go through a data mining process. Now, there are a wide range of approaches, techniques, and tools that you can use in order to kind of process the data. However, we're going to start today with the most basic of understanding so you can kind of get an idea of what data processing looks like. So what is data processing? With data processing, you are simply converting raw data into meaningful information through a process, just like its name. Now, why do we manipulate data, or why do we mine our data? In order, because if we have a data set, or if we have a problem that we're trying to solve, with data manipulation, we will be able to kind of get better insights on how we can resolve this problem. Or let's say we have a solution, but we want to improve that solution. And this is where data processing can help us achieve that. Now, it's very similar to a production process if you think of it. So it follows a cycle where, as you can see in this figure, you have inputs or raw data. They are fed into a processing process or a processing, let's say, cycle, which are like computer systems, softwares, algorithms, or models. And then they will help you produce the output, which will lead to valuable information and insights, and will lead you to make better decisions. So why is data processing important today in businesses and in all, let's say, industries? So through data processing, companies can gain valuable insights. They can be able to make better decision-making. They will be able to create better business strategies regarding whatever they are trying to solve. And they will obviously secure a competitive edge by narrowing down the data to kind of highlight the most important information and the most accurate information. Now, when you know the importance of data processing, and you can implement the methods correctly, you will be able to develop better outcomes for your business or for your company. So here are some just brief real-life examples where data processing is used, and whether we realize it or not, data processing is used in our daily lives. And some examples could include, for example, e-commerce companies, they use the search history of customers in order to recommend similar products that their customers are looking for. For example, also when it comes to digital marketing, the companies use demographic data of people in order to strategize the specific campaigns for specific locations for those marketing campaigns. And self-driving cars like Tesla, for example, they use real-time data from sensors in order to detect if there are pedestrians or even other cars on the road. Because there's an AI system built on it. So these are just some real-life examples of how data process is involved and takes a huge part of our lives. So let's move on to kind of the data analysis part. Now, with the rise of Internet of Things, with the rise of the metaverse, with the rise of AI, machine learning, and all these new tools and technologies, the world is becoming more and more data-driven. And of course, we have endless amounts of data available to work with. This is where data analytics comes to play because it is able to process big data into useful information. So what is data analysis? It evaluates data using kind of analytical or even statistical methods or tools in order to help you discover valuable information. Now, once the data is collected and sorted using these specific data analytics tools, algorithms, and models, the results are then made, interpreted in order to help you make the decisions that you want. And these results are usually presented in visualizations such as graphs and charts and such, or dashboards, to kind of help you, summarize your findings. So although many groups, organizations, and experts have different ways of approaching what data analytics is, most of them can agree into like one basic definition, and it is the process of cleaning, changing, processing raw data, and extracting actionable info that helps businesses make valuable decisions. This procedure actually of data analytics helps reduce the risk of risks inherent in decision-making by providing useful insights and statistics, which are, as mentioned, often presented in visuals. So data processing uses specific data analytics techniques and methods for analysis depending on the problem that you are trying to solve. And there are really here 3 steps that we will focus on, and that is, first, you have to select the right model for your data set, you have to train the model you have in hand, and then you will kind of evaluate the model based on the findings or based on what you are trying to solve in the first place and validate your findings. And we will go through this and explore it more as we go through in the presentation. So what's the importance of data analytics? So it helps businesses have a clear focus, if they want to effectively target customers who are likely to buy, for example, their product or their service. It will help solve problems, for example, operational costs. It will help them innovate and be able to design futuristic innovations and solutions. Data analytics will help cut costs, and it will help, of course, attract new customers for companies and such. That being said, we have types of data analytics that we, as data analysts or data scientists, look for in every data science or data analytics project. Now, there are 4 types of data analytics that are used across all the industries. Now, it's important to know that while we separate these into brief categories, they're all kind of linked together and build upon each other. So as we begin moving from the simplest type to the most complex type, of course, the degree of difficulty and resources increases. And of course, at the same time, the level of added value for insights increases as well. So what are the types of data analytics we have? We have descriptive analytics, diagnostic analysis, predictive analysis, and prescriptive analysis. And these help you understand kind of the what, the why, the when, the where, and the how of your data analytics. And it helps you drive the better decision-making that you are trying to make, and enables the organization to meet the business objectives and strategies as well. So next, we will kind of introduce each type and kind of give examples of how these specific analytics types are used or utilized in business. Descriptive analytics is just like its name. So basically, you kind of analyze your data by describing it and summarizing the statistics using historical or past data. So this doesn't really use modeling. It's kind of the foundation of all data insights, and it is the simplest and most common use of data in business today. It kind of answers the what happened by summarizing historical data, usually presented in the form of dashboards. And the most common example is, to track key performance indicators or KPIs, which describe how a business is performing based on specific chosen metrics or benchmarks. So business applications of descriptive analytics could include KPI dashboards. For example, if we want to find the revenue per customer, the average time customers take to pay bills, and these are usually presented in dashboards or visuals or reports or statistic summaries as well. Or also another example of descriptive analysis could be the monthly revenue reports. And also, if you want to have an overview of your sale leads, for example, like how many sales occurred in the last quarter and the quarter before, did they increase, did they decrease? So anything that has to do with kind of descriptive analytics, not heavy modeling, is a type of descriptive analysis. So it kind of answers the what happened with the data using historical data. Diagnostic analysis is just like its name. It helps you understand what the cause of the problem that you have. So after you kind of after you answer the main question of what happened from descriptive, you want to dig deeper and understand the why did it happen, and this is where diagnostic analysis comes into play. It helps you find the causes of the outcomes. So for example, let's talk about some business applications. We have freight companies who investigate the cause of slow shipments in certain regions or areas. And for example, a software as a service company, which drills down to determine which marketing activities increase trials. So that being said, we are trying to look for the cause of why this happened, like you're just trying to dig deeply into why it happened and such. Predictive analysis, in my opinion, this is one of the most important analysis that we use today in data analytics and data science, and it helps you answer the question, what is likely to happen, in order so you can give like a call to action kind of way. So it's mostly revolving around like forecasting, for example, if you want to forecast the weather, forecast the sales, and such. It uses the data we have summarized in order to make logical predictions or outcomes of future events. And this actually analysis relies heavily on statistical modeling, which also requires added technology and manpower to forecast. And it's important to know that, since we deal heavily with forecasting, we need to understand that forecasting is only an estimate, which is the accuracy of predictions relies on quality and detailed data that we have. Now, specific business applications of predictive analysis could include, for example, we have sales forecasting, we have predictive analytics in customer success teams, and for example, we can even use customer segmentation in order to determine which leads have the best chance of converting. So these are just some examples of predictive analytics. And when it comes to predictive analytics, there's actually like specific algorithms that we use in machine learning and that we often use. So we'll be exploring that more and focusing on that specifically more today. The last type of analytics we have is prescriptive analysis. With prescriptive analysis, you kind of have to give like a call to action of what the next step you need to take is for your data. So it kind of helps you determine the course of action to take in a current problem or decision. It utilizes the state-of-art technology and the data practices, and the best example we can give is AI, because AI systems obviously consume large amounts of data every single day and continuously learn on their own in order to make informed decisions. And it's actually, fun fact is, most of the big data-driven companies such as Netflix, Apple, Facebook are actually utilizing prescriptive analytics the most and AI in order to improve their decision making. So that being said, we have kind of briefly introduced the types of analytics we have. Descriptive explains what happened, diagnostic explains why it happened, predictive forecasts what might happen, and prescriptive kind of recommends you a call to action based on the forecast that you are trying to figure out. So that being said, as we said, each type of analytics serve a different purpose depending on, the kind of analytics you have in hand. And, as I mentioned before, they're all kind of connected to each other and rely on each other to a certain degree, which will help you kind of build the kind of insights and the valuable information by the end of the result. So let's talk more about today's topic, which are like the steps of data processing. When it comes to data processing, we have three things. We have selecting the model, building the model, and testing the model. So obviously, once we're done with exploring our data set, the next step that we have to do or take is data processing. Data processing is all about model selection, building, and testing. And this is where kind of the analytical or analysis-heavy approach is kind of put together and tested. Now, there are a few considerations or questions that you can keep in mind when you want to select a specific machine learning model. For example, you can ask, what are the data types that you have in hand? Are they categorical? Are they ordered, continuous, or are they mixed? Is there a time index to consider? Are there like specific rules or constraints that need to be incorporated into the model? And what models have others used for similar problems? So having these questions in the back of your mind while you're dealing with your data set kind of help you understand what exact algorithm you can use or which algorithm will be the right one to use for the specific problem that you're trying to solve. Now, with a few models that you've selected, the next step after you've selected your model is to build the model. And what that means is you build the model, you test it, and you kind of tune it. And this is where kind of the models are configured, validated, and fine-tuned to get better accuracy. Now, what is our goal during all of this? We want to get the best results. How do you get the best results? After you test a few models or build a few models, you want to find which model kind of gives you the highest accuracy and the lowest error rate. This way you would be able to know that your model is performing well and your results are the best. So after selecting, building, and kind of tuning the model, the next step is to actually deploy the model you have in hand. And this means what this means is you want to produce the specific outputs that lead you to make a decision or an action. So some examples of what decisions might look like when you deploy your model is, for example, it will help you kind of understand how you can raise your price. For example, a call to action could be like to launch the promotion of your campaign, change the policy of your company, or change like a mixture. And in data science applications, model deployment is actually often automated while allowing analyst users to override and influence the recommendations of the model. After we've deployed our model, after we've tested it, we've selected it, we've deployed it, the last step in the data processing or data analysis step is to monitor and validate your results and your findings. So you have to always go back and check to see if the outcomes are what you expected in the beginning. You have to go through the whole process and kind of see if your results make sense as a data analyst or a data scientist. And monitoring and validating results can take many forms. For example, like summary reports and simple charts or visuals of actual targets or average revenue or sales over time. So it can kind of help you build or validate what results you're trying to solve from the beginning. Kind of you have to look at the first step, which is your actual objective, and compare it to the final step and see if it makes sense to you. Now, let's dig deeper and kind of understand the different types of algorithms that we have. It's safe to say that obviously machine learning is an integral part of data science projects and such. Now, you must know the various machine learning algorithms that are used for solving different types of problems, because obviously one single algorithm cannot solve any problem that you have. So each use case really depends on the type of algorithm that you need to use. These algorithms can find applications in various tasks. For example, you want to predict the cost of something. You want to classify, for example, email spams, if they are spam or not. If you want to cluster, for example, data into groups, depending on the data set and the problem you have in hand. So we have the machine learning algorithms fall into or are classified into three categories. We have supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, basically, you are training labeled data. So this is basically used to classify something or predict a value. So supervised learning uses either predictive models or classification models. For example, if we have a list of credit card transactions and we want to detect fraudulent transactions, then this is an example of supervised learning. Unsupervised learning, basically, you have data that's unlabeled, that's messy, and it is used to find patterns in the given data that you have. Here, you're kind of asking your model to process the data, from which then will help you draw conclusions. For example, you want to segment your customers based on spending data. The last type of algorithm we have is reinforcement learning, which means it is the closest to how humans learn. And this is basically the model is learning by trial and error. So, for example, personalized recommendations on streaming platforms like YouTube, as well as self-driving cars, these are just examples of how reinforcement learning is. So, when it comes to data processing, one of the most important procedures that we do as data analysts is we have to split our data into a training set or into a testing set. So the training test split procedure is used to estimate the performance of the algorithms that we have in order to help us make predictions on the data and make assumptions on the data that we are not using to train the model. Now, it's important to know that we need some data to train our model on and some data to test our model on to kind of validate the findings that we have. And actually, a fun fact is data scientists have noticed that the ratio of 80-20 or 70-30 are the most widely used ratios that data scientists use today in order to split their data set to give the best results. What that means is studies show that if we use 70-80% of the data set to train your model and the remaining 20-30% to test your model, this will give you the best results possible. So this is usually the range that we use in order to split our data sets. And in supervised learning, we divide the data we have between training and testing. So the training data will go into the algorithm, and that means it will learn from it and it will produce the model that you have. And the testing data will go directly to the model. So it will give you an idea about the performance and how your model performs and such. Now, as I mentioned, there are two types of algorithms for supervised learning. It's either classification models or regression models. Classification models is just like its name. It's used to categorize data into classes or categories. So it refers to a predictive modeling problem where a class label is predicted for a given example of input data. For example, if you want to predict if a transaction is fraud or not, if you want to classify if an email is spam or not, if you have, for example, you want to classify something into yes or no. So anything that has to do with classifying or classes, this is a classification regression problem. They can be used to solve classification problems. Some of the most common ones are identification of spam emails, speech recognition, and identification of cancer cells. Now, when it comes to regression, it's all about prediction. So you have something that you want to predict. You want to predict a specific value. You want to predict, for example, the price of your house. You want to predict the sale price of something else. So this is kind of how they are both categorized. And we will be focusing mostly today on the regression problems. Now, it's important to know, just for you to have an idea, machine learning has supervised learning, unsupervised learning, and reinforcement learning, and under that, you have the types of algorithms used, which are classification, regression, clustering, and decision-making. Under those umbrellas, you have the specific types of algorithms that you can use as a data scientist or data analyst that will help you, based on the problem that you're trying to solve. If you're trying to classify, you can use either, for example, the naive Bayes, decision trees, logistic regression, random forests, and such. If you are trying to predict something, you would use something from regression, such as linear regression. You have decision tree regression, support vector regression, and such. Clustering as well, and decision-making as well. So this is kind of a big summary of the many machine learning algorithms that we have in today's world. So we're just going to talk about the most popular algorithms from supervised learning. So we have a classification problem, which is to predict a discrete class label, and regression, which is to predict a continuous quantity. Three of the most popular, algorithms that we will talk about is logistic regression, naive Bayes, and decision trees. And for regression, we will talk about linear regression, random forest, and multilinear regression. When it comes to classification algorithms, one of the most common models or algorithms that we use is logistic regression. And basically, logistic regression is used to calculate the probability of like a binary yes or no kind of occurrence that you have. So it's a calculation used to predict a binary outcome by the end of the day. Like, is it a pass or is it a fail? So it just helps you kind of decide or make the decision by the end of the algorithm. So for example, we apply machine learning in order to determine if a person is likely to be infected with COVID-19 or not. Some applications of logistic regression could be, for example, in the financial industry, we use logistic regression in order to predict if a transaction is fraudulent or not. And for example, another example could be in marketing, you can use logistic regression to kind of see if a target audience will reply to your survey, for example, or not. And this is the formula or function of how the logistic regression kind of looks like in the figure. The next type of classification algorithm we have is the naive Bayes. And when it comes to naive Bayes, it calculates the probability of an occurrence of an event kind of based on the future. For example, here, the most common example I can give you is, for example, spam filtering, so filtering emails into spam, and, for example, text classification as well. Now, here we have an example. So, for example, in text analysis, naive Bayes can be used to categorize words or phrases that belong to a preset tag or classification or not. For example, here, we have like a sports kind of category, and here the text is, for example, if it's related to sports or not. So the text is a great game, the tag is sports. If it's the election was over, so this is not related to sports, so it's not sports. So this is kind of how naive Bayes kind of works. And here we have the actual function of naive Bayes, which is on the right here. And that kind of helps you calculate how naive Bayes kind of works. The last classification algorithm that we'll talk about today is decision trees. And when it comes to decision trees, it's kind of like a flowchart-like structure, and it has like a trunk, and that will kind of fall under branches, and then under them you have leaves. So it kind of creates categories within categories to kind of help you be able to make the decision that you're looking for. Now, for example, to continue with the sports example, as we can see here on the left down, we have the sports as the main kind of branch. Under it, we have two categories, racket sports and bat sports, and under that, we have those kind of leaves that will show you what falls under racket sports and what fall under bat sports. And for example, here on the right, if we are trying to classify a person as fit or not fit, then this is kind of how a decision tree would look like. Now, let's move on to the most popular regression algorithms. And it's important to know that, when it comes to regression, we are trying to predict like house prices, stock markets, salaries of employees, for example. And these are the most common regression problems that we have in AND. So anything that has to do with predicting a value, this is where you use regression. One of the most common types of regression algorithms we use is linear regression. And it is used to predict the value of a variable based on the value of another variable. So, for example, here, it follows this function y equal b0 plus b1x. And this is kind of the main formula that is used to calculate the linear regression. And in linear regression, the outcome we are trying to find should be a continuous value, so not a discrete value. So it can be any possible value. Here in the graph next to us, this is kind of how a linear regression graph could look like. So on the y-axis, we have the dependent variable. On the x-axis, we have the independent variable. And then we have the line of regression and data points that are surrounding it. And the regression line is the best fit line for a model. And this is where we are trying to find the best line of the algorithm. Random forests, it can look a bit similar to decision trees. However, since decision trees use single trees, random forest uses multiple decision trees in a way to help you predict the output that you're looking for. So it kind of gives you multiple outputs in a way. So you have several decision trees that are then modeled that predict the value of any new data point. And for example, it can be also random forest can be used on both regression tasks, which to predict continuous outputs such as the price, or classification tasks such as predicting categorical or discrete outputs. So it can really be used for both classification and regression problems. The last type of regression that we will focus on today is multilinear regression. It is kind of a continuation on linear regression. However, it uses multiple kind of variables to predict the outcome of a response variable. It is the type of regression where the dependent variable shows a linear relationship with two or more independent variables. And also, it's important to know that it should not be, it can be nonlinear, where the dependent and independent variables don't follow a straight line. Here, just for the sake of time, here we have the formula of the multiple linear regression and how to solve it. So it's exactly like the linear, however, with multiple values that you have. And with multilinear regression, if you want to estimate the relationship between two or more independent variables and one independent variable, that is when you use multilinear regression. So, for example, if the most common, use cases of when we can use multiple linear regression, that is when we want to know, for example, how strong the relationship is between two or more independent variables and one dependent variable. For example, how rainfall, temperature, and the amount of fertilizer added the effect crop growth. Taking the same example, if we want to find the value of the dependent variable of a certain value of the independent variables, what that means is, for example, we want to find the expected yield of a crop at certain levels of the rainfall, temperature, and fertilizer addition. Another example, just to kind of, give you that brief kind of idea, is let's say you are a public health researcher who is interested in social factors that influence heart disease. Now, you want to survey 500 towns and gather data on the percentage of people in each town who smoke, the percentage of people in each town who bike to work, and the percentage of people in each town who have heart diseases. Because you have two independent variables and one dependent variable, and all your variables are quantitative, so you can use multilinear regression to analyze the relationship between each of these factors. And for example, here, we have the rates of heart diseases as a function of biking to work and smoking. This is a continuation of the previous example we just said. So on the y-axis, we have the heart disease or the percentage of population. On the x-axis, we have biking to work or the percentage of the population. So in this figure, we calculated the predicted values of the dependent variable. The dependent variable was the heart disease across the full range of observed values for the percentage of people biking to work. Now, to include the effect of smoking on the independent variable, we calculated these predicted values while holding smoking constant at the minimum, mean, and maximum observed rates of smoking. So this kind of figure gives you an idea of how multilinear regression figure looks like, with the data points scattered around. Now, we've talked all about algorithms, we've talked about data processing steps. Let's actually move into the good part of this. Let's continue the medical insurance cost prediction that we've already started before to kind of help you get an idea of how we applied those steps. Okay, so if you can recall, we've already talked about the medical insurance cost prediction. And in this example, we want to explore a data set of insurance data that we have in order to build a model to predict the cost of treatment for individuals based on specific features such as the age, the gender, BMI, and other information. Now, just very briefly, the description we have in hand, we have the age, we have the gender, we have the BMI of the patient, we have the number of children, we have if people are smokers or not, we have the region or the area of where the patients live, and the charges or the costs, the medical costs billed by the health insurance, which is the main factor that we want to focus on, since our goal by the end of this is to predict the medical cost. First of all, just very briefly and very quickly, just in case we have new online audience or new members here, I'll just take you through very quickly the steps that we've already done. So first of all, we loaded our data set into this Colab, and then just to give you a brief overview, our data set looks like this. So it's in an Excel sheet. We have the age, we have the gender, the BMI, children, if they're a smoker or not, the region, and the charges. So this is kind of just to give you an overview of how it looks like. However, instead of opening this data set this way, let's print the head of the first 10 rows just to kind of see how the data set looks like. So here, using this line of code to display the first 10 rows, we'll use data.head between brackets 10 in order to display the first 10 rows of the data set that we have. Next, after we've seen our data set, we will start by exploring and doing an initial high-level exploration. And so as data analysts or data scientists, this is a very important step that we need to do in the beginning, just to kind of see how many rows and columns we have, if we have any kind of hidden patterns or trends in the data set, and such. So the first thing that we did is we wanted to see how many rows and columns we have in our data set, and by assigning the rows into a data shape and the columns into another data shape, the rows are assigned into 0 and columns into 1, we can see that we have 1,338 rows and 7 columns in the data. Now, we will use the function info, which will help us kind of summarize the summary statistics that we have in hand for the data set. And what that means is the types of data that we have, so integers, floats, objects, and such, missing values, the memory usage, and the number of rows and columns. So now we will actually apply this function, data.info, to give us a summary of the statistics that we have. And it's important to mention here that, as we can see, we have 1,338 rows for all columns except this column. We have 1,335 in the BMI column, which means that we have 3 missing values, which we will have to treat later in the data cleaning and preprocessing step. Now, we will use the function describe to check for the mean, standard deviation, the maximum, minimum, first quartile, second quartile, and third quartile of each feature or each column. So by running this line of code, you will be able to see the mean, the standard deviation, and all these values for the data set that you have in hand. Now, at this stage, we are done with exploratory and initial high-level exploratory data analytics. We will move on to visualizing our data to kind of help us, transform that raw data of numbers and help us, have our insights based on the visuals that we have. The first thing we will do is we want to look at the distribution of charges across our data set. This will help us kind of, know how much patients spend on treatment on average. So by doing that, we're going to be plotting an actual histogram where we have, this is the kind of formula that we use or function. So the data is in charges, the plot, the kind of plot that you have is in a histogram. And then we will look just a bit down. This is kind of showing us the distribution of charges with the frequency on the y-axis and the charges on the x-axis. So from this distribution of charges histogram, we can notice that the lowest charges are spent by the majority of the patients and the highest charges are spent by very few patients. After we've distributed the charges and seen the visual, we will see if smokers spend more or less on treatment than non-smokers. In order to do that, we're going to run this line of code where we will assign the smokers into yes and non-smokers into no. This will help us, kind of categorize how many smokers and how many non-smokers we have. After running this line of code, we found that we have 274 smokers and 1,064 non-smokers. Now we're going to plot the charges for both smokers and non-smokers in order just to get an idea of the visual itself. So here we have the distribution of charges for smokers and distribution of charges for non-smokers. From this graph, we can see that the majority of smoking patients spend around this one. They spend around, let's say, $20,000 on average on their treatment compared to non-smokers who spend around, let's say, $2,000 almost to $5,000 on average. Hence, we obviously can say that smoking patients spend more on health treatment for doing regular checkups, blood tests, health treatments, and such. So after we plotted the distributions for smokers and non-smokers, we will plot the distribution of the age in our data set and then see how the age affects the cost of treatment, which is our output. So we will plot a histogram for this correlation. And before doing that, we will see the age distribution on our data set. And here we can see that the highest kind of number of patients we have are maybe from the age of like 18 to 20. Moving on, we will plot the correlation between the age and the cost of treatment. So in order to do that, we are going to draw a scatter plot to show the correlation. And here, after we've kind of run this line of code, we can see here that the older patients get here, the more they spend on their health treatment due to the issues they have and such. The next thing we will do is we want to check if smoking also affects these curves. So in order to do that, we will show the smokers in the red column and non-smokers in blue, just to get an idea of how it looks like. Let me just zoom out this one for a bit. Okay, yes. So here we can see the smokers are in red, the non-smokers in blue, and this is the cost of treatment for different ages. Now we can see that the non-smokers tend to spend less on their health, obviously, than smokers, regardless of their age that they are in, which obviously confirms our previous findings. The next thing we're going to do is we want to plot the correlation between the BMI and the cost of treatment. Just a reminder, body mass index, this is the formula that we use to calculate it. And then this is kind of a BMI chart just to kind of help you look at the different categories that we have in our data set. So for example, if you are from 18 to 24, you are healthy. If you are from 25 to 29, you're overweight. 30 to 39 is obese, and extremely obese is from 40 to 42. So this is just kind of to have a summary of the different categories that we have. Now we're going to look at the distribution of BMI in our data set and then see how BMI affects the cost of the treatment, which is our output. In order to do that, we're going to draw a histogram to show the distribution of BMI in our data set here. And so as we can see in this histogram, most patients have a BMI almost, let's say, from 27 to 30, which means that most of them, depending on the BMI chart, fall under the overweight or obese categories. So according to the BMI chart above, obesity starts at almost 30 for the BMI. So now we want to investigate the impact of BMI on the cost of treatment. So by running this line of code, we're going to see how many obese people we have, how many underweight people we have, how many healthy people we have, and how many overweight or obese people we have. By running this and assigning the values of each category, we can say that we have 705 people who are obese, 385 people who are overweight, 230 people who are healthy, and 15 people who are underweight. So we can say that most patients in our data set are mostly obese, 705, and extremely obese patients are not included in the data set. We don't have that. After we've seen that, we want to compare the distribution of charges for all these 4 groups, which are obese, overweight, healthy, and underweight, in one plot, which will show the obese in red, overweight in yellow, healthy in green, and overweight data in blue. In order to do that, we're going to plot a histogram here, which shows the distribution of charges. So from this, obviously, since the red is obese, we can see that patients with BMI above 30 who are obese spend the most on treatment, obviously due to the regular checkups that they have to do, the blood tests, and more. Next, we moved on to the data preprocessing. So obviously, we've seen before that the BMI feature had 3 missing values, so we knew that we needed to treat those missing values. So we're going to start by removing those missing data by running this line of code. But before doing that, we're going to see how many missing values we have in each column. So by running this line of code, data is null and then the sum, this will show us that the BMI has 3 missing values. Now, in order to drop, we want to drop the rows with the missing values. So we're going to use this line of code, which is data.drop_NA. So here we can confirm that the BMI, now we don't have any missing values anymore in all features. And in order to confirm that, just for further summary statistics, just to check and have an overview, we're going to use the line of code, which is data.info, just to kind of, again, see the first few kind of rows and columns, and if we have, how many non-values we have, the type of integers or the types of objects that we have, and such. So after we've removed our missing values, we will start by removing unused columns. What does that mean? Now, our main goal is to predict the medical cost charges. So obviously, we have region and we have children, and I don't think they're necessary to keep in our data set. Therefore, we're going to kind of remove those categories in order to have the best results. So we will drop the region and the children feature by running this line of code, and then here, we can confirm that we only have the age, the gender, the BMI, the smoker, and charges. So we can confirm after running the line of code we have above, which is the data.drop, and then we put in between brackets the features that we want to drop. We can confirm that we don't have those anymore. We've dropped them. After we've dropped them, we need to convert categorical or non-numerical columns to numerical. So if we've seen above here just a bit, the gender is classified into female or male. So we want to classify it or convert it from male or female to 0 and 1. So we will assign the male to be 0 and the female to be 1. And also the smoker is from yes to no. So we will also convert it to numerical, which means the smoker will be 1 and the non-smoker will be into 0. So let's convert those columns. We will start with the gender column here. And after running the line of code for it, we can confirm here if the gender is converted into a numerical value. We will do the same for the smokers column. And then we can confirm also that this is numerical. So now we can see that our data set is all clean and ready. The last thing that we have to do is we need to normalize our data using the minimum maximum normalization, meaning that our data should be ranged from 0 to 1. So we used minimum maximum normalization. And in order to do that, the first thing you have to do is to get the maximum of each column. So we got the maximum value of each column, and then we will divide each column by its maximum value. So in order to do that, we will run the data.divide datamax function, and this will help us kind of standardize or normalize our data numbers between 0 and 1. We can confirm here that all our numbers are between 0 and 1, and our data is all clean. The data cleaning pre-processing steps are done, and now our data is ready to go to the last stage, which is data processing and analytics. So when it comes to data processing and analysis, we want to start by building our model. Now, before building our model, we are going to check the importance or impact of each feature in order to drop features that might not be relevant to what we are trying to solve, which is predict the medical cost charges. So here, by running this line of code, this will show us the importance of the features that we have. So let me just here show you. There you go. So on the y-axis, we have the feature, and on the x-axis we have the importance. We can notice here that the smoker is taking the most, kind of contributes the most in predicting the medical charges of a patient, and since it's the most important, followed by the age and then the BMI, we can see that the gender is not really irrelevant to predicting the medical cost charges, which makes sense. So therefore, we're going to drop it just to make it easier for our analysis. So we are going to drop the gender column by dropping it using the same code function we've done before. We want to check if this is done by using the data.describe function to check for summary statistics. As we can see, we only have now age, BMI, smoker, and charges, which confirms that our feature gender is dropped. Now we're going to start by the actual processing of the model. We will be using multilinear regression model for this example, in order to predict the cost of treatment for any new incoming patient that we have. The first thing we have to do, as I mentioned before, is we need to split our data set into a training set or a testing set. So for this example, we've split our data set into training of 80% and testing for 20%. So by running the line of code for the training and testing set here, we can confirm that after splitting our data set, we got two sets. The training set has 1,068 entries or records or rows, and the testing set has 267 entries, which makes sense because obviously we split our data set into the training set, which takes 80%, so we have more entries, and the testing set is 20%, so we have 267 entries, which is less. Now, each set for the training and testing has three input features, which are the age, the BMI, and the smoker, and the output that we have is the charges or the cost of the medical insurance. Now, in order to predict the medical cost or charges of a patient given their age, BMI, and whether they smoke or not, we will build a predictive regression model using the scikit-learn library. Obviously, as mentioned previously, we will build our model using the multilinear regression model to predict the cost. We will define our model here by assigning it to linear regression, and then it will kind of here tell us if our model is trained or not. So it will go through several processes until our model is trained, and then it will confirm that the model is trained. After we've trained our model, as I mentioned previously, it's very important to start by evaluating our model, just to kind of see how well it performs. So we will start by calculating the predicted values for this model using this line of code. And this shows you the y predicted is equal to the model predicted x values of the testing set for the model. Then we will evaluate our model using, how do we evaluate the performance of the model? We have some metrics that we'll use. For example, here we're going to look at the mean absolute error, the mean squared error, and the root mean squared error metrics. So we will put the training and testing set on the metrics, specifically, sorry, the testing set in order to evaluate, and then it will give you these values. So here we have the mean absolute value. Mean absolute error is from 0.065, and then the mean squared error is 0.008, and the root mean squared error is 0.091. What is that? What do these numbers mean? Since our data set is normalized between 0 and 1, we got these values, which is absolutely normal. So an RMSE score of 0.09, MSE score of 0.08, and MAE score of 0.06 are very close to 0. And this is actually considered as excellent because we want to have less error rate as possible in order to make sure our model is performing well. Thus, we can consider our model as being well-performing for this regression use case or problem. And obviously, as I mentioned before, the smaller the error, the better. The last thing we're going to do is we want to kind of validate. How do we do that? We're going to see how our model performs, and we're going to predict the medical charges of a smoking patient. For example, I've set a smoking patient who is 57, has a BMI of 34, which is obese, and he is smoking, okay? We're going to test it. So we assigned the features, 57, smoker, 1 means yes, he's smoking, and the BMI of 34. By running this line of code, which is predicting the values that we have, it will show us, after running it, it will show us that the charges for someone who's 57 with a BMI of 34 and is a smoker, the charges is around $37,358, which confirms our statistical model that it's working and that it is working well. So that being said, we are done with the data processing and analysis part. This is a very simple example just to give you a quick overview of how the kind of process looks like and such. Now, obviously, since we had only 1 hour, we could not cover it into more details. I would highly recommend you to feel free to take a picture if you want, or to screenshot if you are from the online audience. We have some available Microsoft Learn documents or learning paths for you that you can use. And these are very free for you to use. They have a lot of valuable content for you to use as well. So let's open it and just check it out very quickly so you can kind of learn at your own pace and see. So the first learning path that I've added for you here is understanding concepts of data analytics. So it talks about the types of data analytics, the process in more details, and even the types of data, the storage and such. So the module takes only 28 minutes for you to complete. So I would highly recommend you to kind of check it out to have more accurate information that is added to what you are trying to learn. The next learning path that we have is also exploring data analytics concepts, which is related to this session if you would like to learn more. And this is all about exploring and analyzing data using the Python library. So here it will talk about like a common exploration and analysis task and how to use specific Python packages to analyze and process your data as well. I highly recommend this learning module. It has even real-world data that you can examine and such, and so on. Just the last thing I want you to see is when you go on our Microsoft Learn platform, you can see that we have a lot of learning courses and pre-modules for you to check out, whether it's for Power BI, Microsoft Azure, anything that really you can think of, data analytics, anything really that you can think of, Internet of Things and such. We have a lot of those paths available, so definitely check it out and start learning at your own pace. That being said, we are done for today. So thank you all so much for joining me. Thank you to the online audience for joining as well. I just want to tell you that if you are looking to attend the next events that we have, these are the upcoming events that we have. So if you are an Arabic speaker and you're looking to kind of know more about data analytics in Arabic, I will have this data analytics session, which is all about data analytics innovations and applications in several sectors. It will be happening on September 14 here at Astrolabs as well at 6:30 p.m. And if you are looking into getting into understanding concepts into the world of AI, like core concepts and modern applications as well, feel free to join me on September 28th at Astrolabs here as well. It will be a hybrid event, so it will be also recorded, and we will talk all about AI. That's it from my side. Please make sure to join us on our Microsoft Reactor Middle East and Africa platform. Join us so we can grow our community, so you can stay up to date with the latest events that we have, and we can just always be there to kind of grow and build this community. My name is Hadeel, and it was a pleasure to present to you today's presentation. Thank you all so much.